When my students said that they were going to do their final project on synthetic biology, they didn't justify it by saying it's just like computer science. That idea came later. What they said was they wanted to work outside their comfort zone, an idea which I was suspicious meant they wanted to meet new people. In fact, it's always good to have your students try to work hard, to learn something new, to get new skills. In this case, however, it forced them to take a new look at their own way of thinking and to realize that you can organize knowledge in radically different ways. Now, if I knew anything about synthetic biology, it was a vaguely Frankensteinian view. I thought that perhaps it involved some grave robbing, some bizarre equipment that captured lightning from passing thunderstorms, that resulted in a legion of monsters that would be suitable for home or office. However, when I started to look at the literature to begin to understand what the students were doing, I quickly found that synthetic biology had more in common with traditional engineering than I originally anticipated. In fact, synthetic biology builds systems, much as engineering builds systems. Synthetic biologists have created standard biological parts. They use these parts to process information, and they've even developed a fairly fascinating symbolism that's used to express the kind of biological systems that they create. In probing the synthetic biology literature, I came across a lovely and telling paper on a biological half-adder. The half-adder is, of course, a classic computer science problem. George Stibitz, the pioneer from Bell Labs, famously did one on his kitchen using his wife's breadboard to show how digital circuits could be used to compute. They take two binary digits and add them together plus the carry. 0 plus 0 is 0, 1 plus 0, or 0 plus 1 is 1, and 1 plus 1 is 0 plus a carry. While Stibitz made his half-adder using tin cans and wire and flashlight batteries, this paper showed how to make a half-adder with DNA and RNA and binding sites. It was the molecular biological equivalent of Stibitz's machine. Once I worked my way through that paper, I began to realize that synthetic biology, as it's now conceived, is very much an information-centric form of molecular biology with the intent of producing new systems. Reading the paper as a computer scientist, I saw the information as being the center of this field, and that the processing of information was used to influence biology. However, the more I read the papers, the more I realized I was out of my comfort zone. To the synthetic biologists, the biology is the influential factor. It actually influences the collection and processing of information. You cannot read these papers with the same eye as you would a computer science paper. You have to give more precedence to the biology and shrink the role of information to a supportive place. Indeed, the more I read of the literature, the more I recognized that I had truly left my comfort zone. As all scientists and engineers seem to do, they put their own field at the center and say that it has influenced everything else, including, I discovered in one article, a rather strong claim that the influence of synthetic biology was even seen in the computer science papers of our day. My students came back from their project a little tired, a little grateful to be home. Once they had talked about synthetic biology as being exactly like computer science, except in biology. At the end, they were willing to recognize that it had different ideas, different concepts, different ways of organizing knowledge. I don't think any of them are going to be spending their careers in this field. Yet I think it was a good thing for them to do this, to step outside their true comfort zone. Computer science is a broad and inclusive discipline. We have gathered ideas from many, many fields and made them our own. And sometimes, in the process, we forget that others still have different ways of thinking about things, about solving problems, about organizing knowledge. And so, for us too, it's perhaps good to step outside our comfort zone and to truly collaborate with someone else, being the leader in the project. This is David Allen Greer, stepping firmly outside his comfort zone for the Errant hashtag. Thanks for listening.